Okay, so now let's talk about what happens when we're given two masses for something. So when we look at this problem, we're given the mass for 15 grams of NaOH and 46.7 grams of H2SO4. Now, I've already looked these up, but we're going to have the molar masses of 39.997 grams for every mole of NaOH. And we also have 98.079 grams for every mole of this H2SO4. So we can't put grams down on our table, and this goes back to our mass-to-mass stoichiometry. We have to pull it out and start to do our conversions. So I'm just going to start to do this. So with limiting reactants, we have to compare them, but in order to compare them, we have to put them on our table. Ooh, let me put NaOH there, over 1. And for every 1 mole of that, I'm going to have that 39.997 grams. And remember, we're just using good process to cancel out our units. And that's going to give me 0.388 moles of NaOH. And then over here, we got that 46.7 grams of H2SO4. Pop that over 1. Same basis for our conversions. For every 1 mole, I'm going to have 98.079 grams. And that is going to equal 0.476 moles. So if you need, just as a reminder, that's the work to find the moles for this H2SO4. And then we're just going to put them on the table. So this is what I pulled out of my cabinet. I'm saying I have these two things to start, and I need to know what's going to run out when I'm doing my reaction. So my NaOH is that 0.388, and then this one is 0.476. Now my goal is to figure out how much am I going to be able to make before one of these ingredients runs out. So which ingredient is going to run out first? Well, there's an easy little shortcut that I'm going to show you. And the shortcut is that you're going to compare these at a 1-to-1 ratio. So right now we have 2-to-1, and I don't want to do that. So I'm going to have to take this 0.388 divided by 2. When I do that, I'm going to get the result of that. And if I were thinking about it, this would also be 476 divided by 1, so it's 1 by itself. So I'm just trying to set these numbers to 1 to compare them. What will run out first? Now, obviously, this number is smaller, so this is going to be my limit. Now, I'm never going to put these numbers on my table. That fraction is just to see which one I'm going to run out with when I compare them. But I am going to subtract the entire thing, but that's going to get used up. So the whole thing is going to get used up. Now, over here, I'm going to do the same thing that I've been doing before. So I'm going to take that 0.388 moles of NaOH, place that over 1. Now I'm going to use my coefficients to figure out what goes into this bubble, right? So I'm going to use, it's going to be 2 NaOHs for every 1 H2SO4. So it's half of that, and half ends up being 0.194 moles. So that ends up being 0.194 moles. And then I'm just going to subtract. So I'm going to have 0.282 left. So I just went 476 minus 149, you get 282. So which reactant is limiting? Well, that's your NaOH, right? So your NaOH is the thing that limits how much you can make. And which one is in excess? That is the H2SO4. I have an excessive amount. I have a lot of it. I have too much, right? And that's because I have 2.282 left over, which ends up being your answer. Okay. So let's we'll do one more together, and we'll go the full route. So this one has something slightly different that I like pointing out as we go through this. So this time we're going to have a slightly different amounts given. So we have our 15 grams, we have our 3.18 grams of our NaCl. Now the molar mass for for this one, which is the lead nitrate, that is going to be 331.2 grams for every 1 mole. And NaCl is 58.44 grams for every mole. Again, if you need to review how to find molar mass, there's another video for that. So we got to start converting. So we got our 15.050 grams of Pb, and that is NO3, and I have 2 of those. The molar mass for this, so when we do our conversion, 331.2 grams for every 1 mole. We plug this into our calculator, and we get 0.047 moles. Right, so we're going to pop that into our table, 0.047. That's what I'm starting with. That's what I have. So now I have 3.81 grams over 1, and this is for my NaCl. And for every 58.44 grams, I have 1 mole, and that ends up being 0.065. So we're going to put that up here, 0.065. That's moles. Keep our labels on there. So that's all we've done so far. We've just set the problem up. We've put in our before amounts for both of these items. Which one is less? Now, if you were just to look at this, it'd be a little challenging, but remember, we have to set these to 1. So it's 0.065 divided by 1. It's 2, because we're going to use that coefficient. We got 0.047 over 1. So this one is actually the one that ends up being less. So it ends up being 0.0325 versus this one, which is 0.04. So we compare those two. This one is less, so this is my limit. So I'm going to subtract it all. I'm not going to have any left of this when I'm all done. Now I have to figure out what goes into this box. That is my 0.065 moles of NaCl. And then we go into our stoichiometry, which is for every 2 NaCl, I have Pb, I have 1 Pb, NO3, 2. I put that in, it ends up being that 0.0. We'll round this off. It is a little bit bigger. So once we have that, we can just subtract that. So once we subtract it, it's 0.014. And so now we can ask the question after we compare these. So we have our 2 NaCl, so that's our limit. So our limiting reactant here is the NaCl. And what's in excess here is that lead nitrate, so the PbNO3, 2. Now, if I were asking for mass, you would have to convert this final number into mass using that molar mass one more time. So that would be the 0.014 moles over 1. Putting in our molar mass, which is for every 1 mole, I'm going to have that 331.2 grams, and times the amount, and we're going to have 4.6 grams of Pb NO3 2 left. And that's our final answer. So that's how we find the molar mass for all of these things. That's how we find it through stoichiometry. And I hope that helps. Talk to me soon if you need help.